Assalamu alaikum. Now we will discuss Kepler's laws and the last topic, which is 7.2. So what shape do planets move in according to Kepler's first law? So before we start with the question, I want you to give you a glance about Kepler's first law or Kepler's laws. All planets orbit the sun in elliptical paths. The sun is one focus, not at the center. And the last one, the orbit may look nearly circular, but it's ellipse. Okay. So what shape do planets? So this is for Kepler's first law. It is elliptical shape. In an elliptical orbit, where is the sun located? The sun located at one of the two foci points. Okay. Which is as we explained in the summary just now. For question 48. Let's have some notes. The planet moves faster near the sun. It moves slower from the sun. So this skips the area, sweeps out time, unit constant. So this is according to Kepler's second law, which is divides the areas into equal parts. So how does planet speed change as it moves closer to the sun? Closer to the sun means it speeds up. So for the last part, we have here a question. Before that, I will give you some formulas. So the period squared have a relationship between the radius cube, okay? Or in terms, t squared equal 4 pi squared r cube over gm, okay? So let's check question 49a. Let's read the formulas. Phobos and Deimos are two moons of Mars that move approximately circular orbits. The radius of Phobos, which is 9.4 r1, and its elliptical, which is time. Here, the time you need to change it into seconds always. Okay, so time is equal to 7.7 in hours multiplied by 60 minutes multiplied by 60 seconds. So it will be 27720 seconds. So using Kepler's third law, he needs what? The mass. He needs m. So t squared is 20 squared equal 4 pi squared times the radius cubed, which is 9.4 times 10 to the power 6 cube, over g, which is 6.67 times 10 to the power negative 11 times m. Again, here please do not try to do shift solve, do it mathematically. M equals 6.4 times 10 to the 23 kilogram. If you know, or if you don't know how to do it, rearrange the formula or the initial formula, it's easier for you. So m equal to what? 4 pi squared r cube over g t squared. Okay, straight away. For part B, if the orbital period for Deimos is 30 hours, what is the radius? So using Kepler's law, which is TA over TB squared equal RA over RB cubed. So TA, you don't need to, you can change it to seconds, but you don't need, since it will cancel with each other, equal the one that we need, which is R over 9.4 times 10 to the power 6 cubed. Using the calculator, R will be equal to 2.3 times 10 to the power 7 meters. The last question, what does the equation below confirm? The equation below confirms Kepler's third law. And thank you.